Lightning is a powerful and dangerous natural phenomenon. Understanding how to protect property from lightning strikes is crucial, especially in areas prone to thunderstorms. Firstly, consider the grounding system of a building. A properly installed grounding system provides a low-resistance path for lightning current to follow to the earth, reducing the risk of damage to the structure and electrical systems. This system typically consists of ground rods, grounding conductors, and bonding connections. The ground rods should be installed deep into the earth, and the grounding conductors should be securely connected to the electrical service panel and other metallic components of the building. Secondly, implement surge protection devices, or SPDs. Surge protection devices are designed to protect electronic equipment from voltage spikes caused by lightning strikes and other electrical disturbances. These devices work by diverting excess voltage to the ground, preventing it from reaching sensitive electronic components. Surge protection devices should be installed at the electrical service panel to protect the entire building, as well as at individual outlets to protect specific electronic devices. Thirdly, consider lightning rods. Lightning rods are designed to intercept lightning strikes and provide a safe path for the current to flow to the ground. These rods are typically installed on the roof of a building and are connected to the grounding system. While lightning rods can be effective in preventing direct lightning strikes to a building, they do not eliminate the risk of damage from nearby strikes. Fourthly, inspect and maintain electrical systems. Regular inspection and maintenance of electrical systems can help to identify and address potential hazards before they cause problems. This includes checking for loose connections, damaged wiring, and corroded components. It is also important to ensure that all electrical work is performed by a qualified electrician. Fifthly, unplug electronic devices during thunderstorms. During a thunderstorm, it is best to unplug electronic devices to protect them from voltage surges. Even if a building is equipped with surge protection devices, it is still possible for voltage spikes to damage sensitive electronic components. Sixthly, stay informed about weather conditions. Monitoring weather forecasts and alerts can help individuals prepare for thunderstorms and take appropriate safety precautions. This includes seeking shelter indoors and avoiding outdoor activities during severe weather. Seventhly, consider the location. Areas with higher lightning strike frequencies require more robust protection measures. Structures in exposed locations, such as hilltops or open fields, are at greater risk of being struck by lightning. Eighthly, ensure proper bonding. Bonding is the process of connecting metallic components of a building together to create a common electrical potential. This helps to reduce the risk of voltage differences that can cause electrical shock or damage to equipment. Bonding should be performed on all metallic pipes, ducts, and structural steel components of a building. Ninthly, understand the limitations. No lightning protection system can guarantee complete protection from lightning strikes. However, a well-designed and properly installed system can significantly reduce the risk of damage and injury. Tenthly, follow safety guidelines. Adhering to safety guidelines during thunderstorms can help to minimize the risk of injury. This includes staying indoors, avoiding contact with water, and staying away from windows and doors. Understanding the science behind lightning can further inform protection strategies. Lightning is a discharge of static electricity that occurs between clouds, between a cloud and the air, or between a cloud and the ground. It is caused by the buildup of electrical charges in the atmosphere, which can result from the movement of air masses, the collision of ice crystals in clouds, and other atmospheric processes. When the electrical charge becomes strong enough, a channel of ionized air forms, creating a path for the lightning to travel. Lightning can travel at speeds of up to 270,000 miles per hour and can generate temperatures of up to 50,000 degrees Fahrenheit. The most common type of lightning is cloud-to-ground lightning, which occurs when a discharge of electricity travels from a cloud to the ground. This type of lightning can be extremely dangerous and can cause significant damage to property. Grounding systems work by providing a low-resistance path for lightning current to follow to the earth. The grounding system typically consists of ground rods, grounding conductors, and bonding connections. The ground rods are installed deep into the earth to provide a good electrical connection to the ground. The grounding conductors are used to connect the ground rods to the electrical service panel and other metallic components of the building. Bonding connections are used to connect metallic components of the building together to create a common electrical potential. Surge protection devices, or SPDs, are designed to protect electronic equipment from voltage spikes caused by lightning strikes and other electrical disturbances. These devices work by diverting excess voltage to the ground, preventing it from reaching sensitive electronic components. Surge protection devices typically consist of metal oxide varistors, or MOVs, which are semiconductor devices that change their resistance based on the voltage applied to them. When a voltage spike occurs, the MOV resistance decreases, allowing the excess voltage to flow to the ground. There are several different types of surge protection devices available, including whole-house surge protectors, which are installed at the electrical service panel, and point-of-view surge protectors, which are plugged into individual outlets. Whole-house surge protectors provide the most comprehensive protection, as they protect the entire building from voltage spikes. Point-of-view surge protectors provide protection for individual electronic devices. Lightning rods are designed to intercept lightning strikes and provide a safe path for the current to flow to the ground. These rods are typically installed on the roof of a building and are connected to the grounding system. Lightning rods work by creating a conductive path for the lightning to follow to the ground, preventing it from striking the building itself. Lightning rods are typically made of copper or aluminum and are designed to withstand the high currents and temperatures generated by lightning strikes. The National Electrical Code, or NEC, provides guidelines for the installation of lightning protection systems. The NEC specifies the requirements for grounding conductors, bonding connections, and surge protection devices. The NEC also provides guidance on the placement of lightning rods and the design of grounding systems. It is important to consult the NEC when designing and installing a lightning protection system to ensure that it meets the required safety standards. Regular inspection and maintenance of lightning protection systems is essential to ensure that they are functioning properly. Grounding systems should be inspected regularly to ensure that the ground rods are still properly connected and that the grounding conductors are not corroded. Surge protection devices should be tested periodically to ensure that they are still functioning properly. Lightning rods should be inspected to ensure that they are not damaged or corroded. The location of a building can also affect its risk of being struck by lightning. Buildings in exposed locations, such as hilltops or open fields, are at greater risk of being struck by lightning than buildings in sheltered locations. Buildings that are taller than surrounding structures are also at greater risk of being struck by lightning. The type of construction of a building can also affect its risk of being struck by lightning. Buildings with metal roofs and metal siding are more likely to be struck by lightning than buildings with non-metallic roofs and siding. The presence of trees near a building can also affect its risk of being struck by lightning. Trees can act as conductors of electricity, increasing the risk of lightning striking a building. During a thunderstorm, it is important to take safety precautions to minimize the risk of injury. Stay indoors and avoid contact with water. Do not use electronic devices, such as telephones or computers. Stay away from windows indoors. If you are caught outdoors during a thunderstorm, seek shelter in a low-lying area, such as a ditch or ravine. Avoid standing under tall trees or near metal objects. Crouching low to the ground can also help to reduce the risk of being struck by lightning. Consider professional installation. The installation of lightning protection systems and surge protection devices should be performed by a qualified electrician or lightning protection specialist. These professionals have the knowledge and experience to properly design and install these systems to ensure that they meet the required safety standards. Keeping informed on new technology is helpful. New technologies and products are constantly being developed to improve lightning protection. Staying informed about these advancements can help individuals make informed decisions about how to protect their property. Regular updates to electrical systems can also help with lightning protection. Upgrading electrical systems with modern components can improve their ability to withstand voltage spikes and other electrical disturbances. This includes replacing outdated wiring, installing surge protection devices, and ensuring that the grounding system is up to code. Insurance coverage considerations are helpful. Reviewing insurance policies to ensure that they provide adequate coverage for lightning damage is important. Some insurance policies may not cover all types of lightning damage, so it is important to understand the terms and conditions of the policy. Preparing a plan for how to restore power after a thunderstorm can be beneficial. Having a plan for how to restore power after a thunderstorm can help to minimize the disruption caused by power outages. This includes having a backup generator, stocking up on supplies, and knowing how to contact the utility company. Educating the family is an important part of safety. Educating family members about lightning safety is essential to ensure that everyone knows how to protect themselves during a thunderstorm. This includes teaching children to stay indoors during thunderstorms and to avoid contact with water. Also, it is important to inspect trees on your property. Inspecting trees on a property for signs of damage or disease is essential to prevent them from falling on buildings during a thunderstorm. Damaged or diseased trees should be removed or trimmed by a qualified arborist. In conclusion, protecting property from lightning strikes requires a comprehensive approach that includes grounding systems, surge protection devices, lightning rods, and other safety measures. By taking these steps, individuals can significantly reduce the risk of damage and injury from lightning strikes. These measures are particularly important in locations like Florida, which are subject to frequent lightning storms. The information provided is a general guide, and consulting with qualified professionals is always recommended for specific situations.